This video explains the document database sample application, and it's found at this URL here in GitHub. Right, so here is the sample application, and it's actually a very simple weather application. It reads weather observations from some public APIs of meteorological institutes and store the observations in the document database, and then use that data to calculate some weather information. Actually, the only thing that's implemented is to calculate the average temperature. Right, so the purpose of the application is not so much to illustrate what a document database actually is, but rather to show how a document database can be accessed from a Java program. So that's the purpose of the application, and the purpose of the video is to explain the application. It is not the goal here to explain what a document database is or to compare it with a relational database, because that is covered in the PDF that you can find in the same page in Canvas where you found this video. I will just say a few words here to introduce document databases, because I was thinking that some things are better explained by drawing an image perhaps than by reading or writing text. Right, so first then a few words about what a document database actually is. So first, in the relational database, let's say that this thing in red over here is a table in the relational database. So in the relational database we store data in tables. Each table has a number of columns and a number of rows. Of course, we could call them, the table might be called relation and the row might be called the tuple, and so on. But anyway, the structure is this. And let's say that this is a person table. So the table has a name, it's defined in a schema. The columns have names, for example, age and the person number, and they are also defined in the schema. And all data must follow this structure, which is defined in the schema, and eventual constraints defined in the schema, and so on. Okay, in the document database, in blue here, it's quite different. Instead of tables, we have collections. So a collection, this is a collection, let's say, also have a name. This collection might then be the person collection. And the collection also stores a set of records or tuples or whatever we call them. But in a document database, they are actually called documents. Each record is a document. There is no schema. There is nothing defining that this document database has a collection called person, or what is defined in each document in that collection. It's just what we create, it's there. What we put, it's there. So instead, well, I just said there is no schema. That's actually not really true. It's better to say there is no predefined schema. There is a schema, but it's stored together with the data. So that means that a document consists of a set of fields which are named. So here this document might, if it stores the same data as over here in the relational database, it should have a field with the name age. This person is perhaps 47 years old. The field whose name is PNR. The same names as over here if we store the same data. And whatever, what is, now it's 2020 minus 47. When should this person be born? 73, right? Whatever person number this person has. Okay, so the schema is stored together with the data in the sense that the document consists of named values. And it's good to think of, actually it's often the case, that a document is stored as a JSON object or something JSON-like at least. So here it would be a JSON object, let's say, which has a field called age, whose value is 47, and a field called PNR, whose value is this here. Let's say it's a string, and so on. And that's the JSON document. Okay, it could be stored like this. We are also free to include other documents, JSON documents in this document, nested documents that is, with some fields. We might also include arrays if we wish, JSON arrays, and so on. And then end of the entire document. So this would correspond to that. And it's the entire document. Here is the entire document that's stored in the document database. Okay, so this is what the document database looks like. We just write any JSON object in the collection, and there's no requirement on the structure or what fields should be contained or such things. So there's no requirement saying that each document must hold the same data. They can be how unrelated we wish. There's even nothing saying that each document in this collection has to represent the person. Of course, it would be very bad design if we stored a document representing something completely different in the person collection. But there's nothing in the document database as such stopping us from doing that. Okay, so the good news is, of course, that it's very flexible. If we receive a lot of unstructured data, it's easy to store that data, as is the case here in the weather application, where we receive data in the form of JSON documents from different APIs. And in fact, each API has its own format. So it's very easy to write. Okay, everything we have to do is to dump the loaded observation in form of a JSON document into the database. That's the good news. The bad news is that it's the harder to read. We have just a bunch of completely unstructured data, so it's hard to extract the data from that collection. Okay, but the purpose, as I said previously, is not to compare document database and relational database. So let's stop with that here and instead move to the program. Okay, so there's a README here, which explains how to execute the program. And as can be seen here, you are advised to first have a look at this tutorial, which explains the basics of accessing MongoDB from a Java program. There are more pages in this tutorial, but I think it's sufficient to look at this one. And it might also be a good idea to look at this tutorial here, which explains how to set up MongoDB in the MongoDB Atlas cloud service. That way you don't have to install MongoDB locally, and that is actually how it's used in this application. You might install it locally if you wish, but okay, that's one option. Anyway, you must have access to a MongoDB database somewhere. Right, because this application uses MongoDB. So MongoDB is one implementation of a document database, and that's the one used here. Okay, here in the README, I also like to highlight that you have to set these environment variables. So this contains the secrets. The first is the URL to the MongoDB database to which the program will connect. And it contains the password, so that's why it's a secret. And then there are the keys for the APIs. So it's free to register at these APIs, but you need to register in order to get the key and be able to use the APIs. So if you want to test run this program, you have to register with OpenWeatherMap and WeatherBit and receive the keys and place them in environment variables. And why in environment variables and not in programs? Well, it's a very good practice and common to store secrets, actually store any kind of configuration in environment variables, because that way it's easy for everyone to set up their own environment variables, and you don't have to reveal your settings in the repository in GitHub. Right, so how to set an environment variable depends on which operating system you're using. I'm using Ubuntu. I type export the name WeatherDB server, I think it was, equals, and then the URL, the value of that environment variable. Okay, but I've already done that, and I won't show you because it contains my password and my keys for the public APIs. Right, but instead I'll show how to execute the program. So first we compile nvn clean to remove previous compilations, install, or just compile. That's it. Okay, then exec :java to run it. It displays a prompt, and there are some commands. Load will load data from the APIs. Let's load. Okay, data was loaded. Start will start a thread that will load data once per hour, and stop will stop that thread. I won't do that here. The first loading is done after 1 hour, so it starts with the interval, so no point in waiting 1 hour. And AVG calculates the average temperature. Actually, it's hard-coded that it loads temperatures for Stockholm. So this is the average temperature in Stockholm of all readings, no matter of all readings stored in this database by this program. Right, and of course quits the application. So that's the application. Now let's look at the code. So first we can see that the main method is here in the class app, and I structured it a bit differently here than previous examples in the course, because the app class here, as you see, is not in a layer called startup, but is rather in the root. SEKTH IV 1351 weather data, I think it's called. So it's in the root, not in the startup package. And that is in fact quite common way of placing the class responsible for starting the application. Now let's have a look at the different layers. So first there is the view layer, which is, well, there's nothing particularly interesting there actually. There is the command class, which defines all commands. It's an enum, which defines all commands that can be performed. And then there's the command line class, which does the parsing of the user input. So I'm not going to cover this class here. There's nothing particularly exciting here. It reads a string of user input and extracts the command and the parameters to that command. Okay, then there's the blocking interpreter, which might be a little bit more interesting, but not very exciting either, I'd say. It mainly consists of the method handle commands, which stays in a loop, this while loop here, where it reads input, this method here, from user input that is, passes it to the command line class, or to an object of the command line class, and then there's a switch statement executing the command that was given by the user. It's not the best way to write a command line interpreter, but it's fairly well structured, and it's quite easy and straightforward for a simple application like this. Okay, so then there are the commands. And as we saw previously, load loads all APIs, starts the hourly loading, stops it, and average calculate the average temperature. Right, and as you can see, they all call the controller, which is what the view is supposed to do. So in the controller layer, there is just the controller class, and the controller, well, has these methods, one method per system operation, which is what is intended, right? One action from the user should result in one call to the controller, and then the controller calls integration and model layers as required. Okay, that was the controller. So we'll look in more detail at some methods in the controller later. First, let's just have a look at all the layers. So the model layer is actually empty. As you see, there are no classes in the model. And that is not uncommon for data shuffling application like this. This application doesn't do much. It just stores data and reads data. So no much point in representing the data as Java objects if nothing is done to them anyway. So it's empty. And as I said, that is not uncommon for data shuffling applications that having no business logic, at least not for smaller such applications, and this is a quite small application. Okay, then there's the integration layer where the interesting things happen. There is the Weather API client class, which is responsible for loading data from the APIs, and most interesting of all, the Weather DAO, database access object, which is responsible for calling the Mongo database. So this is where we actually see how a document database is used. Okay, that was an overview of the application, and now let's look at some parts in more detail. So first, let's look briefly at calling the Weather APIs in Weather API client, and then more thoroughly at the database access. So first look at, we can start in the controller actually. So to load data, the view calls the method load from all APIs, and all it actually does is to call a load from all APIs in the Weather API to read the data. That method will return a list containing strings. So each string is a JSON object with data from an API. And then the controller just passes those strings to the DAO and the method store observations, which will write them to the database. So let's start with the loading from the APIs in Weather API client. So it's hard-coded from which APIs to load, and the URLs of those APIs are stored in this Weather Services list, and they are stored here in the constructor. So these are the URLs, and the environment variables that we talked about previously are read by calling the system.getEnv method, which will return the value of the specified environment variable. And here we see the names of those variables: open weather map key and weather bit key. Okay, so those are the URLs from which data will be loaded. So the method load from all APIs is here, and actually I will not cover it in detail. It's not the goal of the application. I mean, it's just there to have some data to work with. The goal of the application is not to show how to load data from APIs. It simply makes HTTP GET calls to the APIs. Opens a connection, sends an HTTP GET requests, and in response it will receive a JSON object. And to do that, it uses an HTTP client API called OKHTTP, which, if you wish, you can read more about here. It's this URL here. But it's not important. It's not required to understand this in order to understand how the application accesses the document database. I just show here that there's this string where responses are stored, and here there's a loop looping through all the URLs in the Weather Services list that we just looked at. And for each of those, it executes a call, makes an HTTP request, and in return it will get the response. And if the response is successful, meaning the HTTP status code starts with 2 or 3, then it will handle that response. It will store that response in the list of responses, this one, which is created here, and return it to the controller. If the response was not successful, then it's just silently ignored. Okay, that's that about this thing. Back to the controller. So now we have this list of JSON objects in string format. Each string is a JSON object containing a weather observation from one of the APIs. Okay, but then we go to store observations in the weather DAO, and now we'll have a look at this in a bit more detail. So first, let's see how this DAO connects to the database. Immediately in the constructor, call connect to weather.DB here. So it also needs to read the content of an environment variable, namely weather.DB server, which is supposed to contain the URL to the database that is to be used. And then this MongoDB Java driver is used this way. We call the create method in the class Mongo clients and pass in the URL, and it will return a connection. And the connection is a field in the class. So now we have a connection to the database. And then we are in the store observations method, which we just saw was called by the controller here after data had been loaded from the APIs. Okay, so here we first retrieve the database. DB name here is defined, as you can see, that way, and its value is weather.db. So we create a representation of the weather.db database, which is stored in this variable here, and then we call get collection on that one to retrieve the collection, which is called the weather data, and then we get a Mongo collection, which is stored in the variable weather call. So that's our representation of the collection. So remember that a document database consists of collections of documents, and this database has just one collection called weather data, and that is represented by the Mongo collection object stored in the weather call variable. Okay, so then we loop over the observations. This is the list of JSON objects representing observations that was passed to this method. And for each of them, we just call insert one on the collection, which will insert one document. And to do that, we have to parse it first. And this static method parse in the document class parses a JSON object, which is what is stored in observation, and converts it to a format that is appropriate for MongoDB. And then we just send it to insert one, and it's stored. So this is the good news, right? It's very easy to store data. No matter the structure of the data, we just pass it to the collection, and it's there. It's stored in the database. No need to understand which field corresponds to which column, or split it into tables or anything like that. Just to dump it to the database. So that's the good news. It could at least be considered to be good news, I suppose. It's easy to store. Now I want to show you the content of this collection to show that different documents actually have different format. So as you can see, these two are from the same weather API. They have similar format. This one is from another API and has completely different format, but MongoDB doesn't care about that. And that's how a document database is supposed to work. We can store any object of any format. Also, you can see here that they have JSON-like format. Let's see, is there something in here? Yeah, here we have an array, for example. Here we have some object. And the whole thing can be considered a JSON object. Okay, so that's the good news, as I said. Now it was quick and easy to insert the data into the database. Then, to see the bad news, we look at the method getAverageTemp, which is supposed to calculate the average of all temperature observations. So first it will call the method findAllTemp readings in the weather DAO, which will return a list of doubles, and each double is a temperature that was received from some weather API. So it will simply extract the temperature from all weather observations that are stored in the weather data collection. And these two lines calculate the average. Okay, and here we could in fact argue that these two lines, which calculate the average temperature, belong in the model because they contain some logic and should not be in the controller. That's a good point, and it could definitely be done like that. First of all, I'd like to say that it's not that we are forbidden to do some arithmetic calculation in the controller. The question is rather if this is business logic or not. And okay, nothing wrong in moving this to the model, I would say, but on the other hand, maybe nothing much wrong in keeping it here either, at least at this point when the application is really small. If we moved it to the model, we would have to create an object in the model that stored all temperature readings, or maybe a list of an object containing temperature readings. But I mean, that's the risk that we would end up with a very, very simple DTO-like object that just stored a temperature and had a method to return that temperature, a getter method. I think for now it's fine to keep this in the controller, but we should be alert that this might be a problem. And as the program grows, maybe we see more things that would make sense in the model, and then at some point we have to start creating the model and actually store data in objects in the model. Right or wrong, now the program looks like this. But so let's instead focus on this method, find all temp readings, which reads from the collection, the weather data collection. And as I said, this is the bad news. Now we have to extract the temperature from all those observations. Let's have a look at the observations. Okay, so in this object here, we see no temperature, but I think it's in the main object. There it is. So it's in a wrapped JSON object called main, and the name of the temperature field is temp, and it's stored, as can be seen here, in Kelvin. Okay, that's one way, a wrapped object called main, a field called temperature, and it's in Kelvin. And over here we start instead with an array which contains an object, and in that object we have the temperature over here, and it's stored in degrees Celsius and has no decimals. In the other reading over here it had decimals. Okay, so not much in common between those two. Different units, different types, with and without decimal, and in different data structures. In one, here it was in an object at the top level. Here it was, I think, in an object in an array at the top level. So all they have in common is that they are both called temp, and that's what I used in the application here. So actually what I did here was to flatten the objects, extract all fields from all wrapped data structures, wrapped objects or wrapped arrays or whatever, and just create one hash map containing all fields in all wrapped data structures in the document, and then look for a field called name. So I didn't follow. I thought this was more general. I could have just followed, used the fact that I know here that I should look, for example, for a wrapped object called main and the field temp in that, but then I would depend on the fact that the object was called main and was an object. I thought this way, extracting all fields in all wrapped data structures, just depend on the fact that the temperature field is called temp. If later we access another API that has another completely different structure of its JSON object representing its observations, and maybe another name for the temperature field, then we would have to look for fields of that name as well. But at least we don't have to care about the data structure of that new API. Okay, we're in really deep trouble if some meteorological institute calls its temperature field not temp, but something else that has another meaning in an observation from another meteorological institute. Okay, so already now we see that it's messy to read data, to extract data from this kind of unstructured data collections. No surprise, of course, if the data is unstructured, it's unstructured, and we have to do some work to extract. Okay, so what's done here? First, we retrieved a MongoDB object representing the database stored here in the WeatherDB variable. Then we retrieve the weather data collection stored here in the weather call variable and represented by an instance of Mongo collection. Then we extract all documents from that collection by calling the find method. And the iterator method creates an iterator over the collection of all those JSON documents that were found in that collection. And that iterator is stored in the observations variable, which is of type Mongo cursor. Okay, so now we have the observations variable. That's the end result. It's a data structure containing all documents in the weather data collection. So simply all data that was ever stored in there. Okay, then we create this variable, this list temp readings, where we intend to store each temperature. So now what remains is to extract the temperature from each of the documents in this observations collection. So this is the way to loop through such a collection using this MongoDB driver. We check if there are any more elements in this collection. If so, we extract the next by calling next. And observations.next will return a document representing one document in the weather data collection. We pass that to extract temp reading, which is a private method in here with the purpose of extracting the temperature field. So here in extract temp reading, we simply call flatten doc, which is this private method here that I won't go through. It's somewhat messy. What it does is to extract all fields in all nested data structures, either fields at the top level or fields in objects or in objects or whatever. And if there are arrays, it goes through all the elements in the array and extracts all fields from all objects in that array. So simply all fields that was stored at any level in this document. Then we have a flattened document, which is represented as a map with key value pairs, and those key value pairs are fields in the document that was stored in the document database. Then we extract the field that was called temp. Temp field name is in fact defined here. So temp, right? We want the value of the field called temp, which we assume is the temperature. We pass that to this convert temp to double, because remember, in one of the APIs returned it as an integer and another as a double. So we have to convert them to the same type. And that's done here in convert temp to double. Here we convert it to a double. Whether originally it was a double or not, it's now converted to a double and returned as a double. And then remember, one of the APIs stored it as in Kelvin and the other in Celsius, and we convert everything to Celsius. So that's this thing here. This method is in Kelvin, decides whether it's in Kelvin or not. So I simply assume that there will never be a reading of over 200 degrees Celsius. So if it's over 200, it's in Kelvin. Also, I assume there will never be a reading below 73 degrees Celsius. So if it's above 200, it's Kelvin, otherwise it's not. I don't know if we can be sure that it's always a valid assumption, but okay, that's how it is in this program. Okay, and then if it is in Kelvin, we convert to Celsius by subtracting this number. And there's no check for Fahrenheit, so if it's not in Kelvin, it's in Celsius, and then we just return it. Of course, converting Celsius to Celsius, you do nothing. So that's it. So that code extracted one temperature reading from one document. And back here in the find all temp readings, that was called from the controller. So we extract the temperature reading, and if we found a temperature reading, we add it to this list here, which was defined here, and is the list where we store all temperature readings, and then we return that list to the controller when we have gone through all documents stored in the collection in the database. Okay, so there's quite a lot of Java. Well, considering the small work that is done, I would say there's quite a lot of Java code. And that's the bad news. It's hard to extract data from completely unstructured collection. Okay, we're back in the controller, and we saw this code already, so we now have the list with all temperature readings, one double value for each temperature observation that was loaded. And okay, this line here, sum, is a way to sum that. We could have just written a for loop that looped through the whole list and summed all the elements in that list. And that's the same thing that's done here. I don't think a few words about this line. So we start with the list, temp readings, then create a stream, which is a way to, well, you can think of it as the stream method passing one element at a time from that list to the next chain method, which is called map to double, which converts each element in that list from an object of the class double to an instance, to a value of the primitive type double with lowercase d, and then pass that to the sum method, which just sums them all. So it's the same thing as creating a for loop, summing all those elements. Right, and that was all there is in this program. So this was an example of how to read and write in a document database from a Java program.